Welcome to this video. In this video, I am going to show you a low-cost technique for development and implementation of Arduino-based SCADA system for motor control. The aim of this video is to show creating Arduino-based PC motor control application and interfacing Arduino with CX Supervisor, which is a SCADA software for building PC-based user interface for monitoring and control. The main operation in this project is to run the DC motor in forward or reverse direction, changes the speed of the motor and indicate the speed of the motor. There is also an option for showing the motor speed in 10 gram. Increasing or decreasing the speed of the motor is performed by giving PWM signal to the motor driver L298N from the Arduino UNO board through its pin number 9. Arduino pin number 8 and 12 give the digital output to the motor driver to run the motor in forward or reverse direction. For measuring the speed of the motor, IR obstacle sensor is used. This sensor senses the speed of the motor and gives pulse output to the Arduino pin number 2. A 100 picofarad capacitor is connected parallel with the sensor output to stabilize the output of the sensor. Now, all this motor control application are performed in PC-based SCADA interface. This interface is developed in CX Supervisor software. Arduino UNO board is connected to the PC via USB cable. This SCADA system is establishes a serial communication with the Arduino UNO board to perform the SCADA-based motor control operation. Before starting this project, let's go to have an idea on how to implement this project. First, make all necessary hardware connection for the Arduino UNO microcontroller with all other components. What we have to do next is to create a Arduino sketch program and download this program on Arduino UNO microcontroller. Now, for creating a SCADA user interface, select a SCADA software. I have a SCADA software CX Supervisor already installed on my PC. CX Supervisor is a all-known SCADA software developed on proprietary basis for creating SCADA application for the Omron PLC. So, CX Supervisor cannot directly communicate with the other controller except for the PLC from Omron brands. But the CX Supervisor supports accepting all OPC data from any OPC server. So we have to select a Arduino OPC server, which is a server software specially designed for Arduino microcontroller, and this server can read data from Arduino IO data from in OPC format, that is a standard format from the Arduino UNO microcontroller, and provide this data to any OPC client software, in this case CX Supervisor software. So next, we have to download Arduino OPC server software from online, install this software on PC, and finally configure it so that the server, OPC server, can communicate with the Arduino UNO microcontroller. Next, we have to create a SCADA interface in CX Supervisor software, and also we have to configure it properly so that this SCADA application can communicate with the Arduino OPC server. When both the Arduino OPC server SCADA application run on PC and Arduino microcontroller is connected with the PC, SCADA application sends the records or Arduino IO data to the Arduino OPC server, and OPC server retyped all the Arduino IO data by directly communicating with Arduino UNO microcontroller and provide this data to SCADA applications. This is how a OPC works on any controller like PLC. In this case, Arduino UNO microcontroller acts like a PLC. We can summarize the project implementation procedure following these steps. Perform hardware connection for Arduino UNO with all other components. Program an Arduino UNO for serial communication with an OPC server. Download and install Arduino OPC server with proper configuration. Create a OPC compliant SCADA interface in CX Supervisor software and configure it for communication with an OPC server for Arduino. In the rest of this video, we are going to implement this project step by step. These are the hardware components for my project. This is the Arduino UNO microcontroller, and this is the motor driver L298N. This 12 volt DC motor, and here is the IR obstacle sensor for measuring the speed of this motor. Here is the connection point for 12 volt DC supply connected to the motor driver. The output of motor driver connected to this motor, and the signal input from Arduino UNO microcontroller. All these components are connected according to the circuit diagram described earlier in this video. So for details about the connection of this component, please follow the circuit diagram in this video. Now I will connect the Arduino UNO board with the PC. And also connect the power supply. This is the power supply, and this is the IR sensor. Note that there is object connected to this disk, and when this disk come near the IR sensor, the IR sensor gives a output to the Arduino UNO microcontroller. So let's go to the program for Arduino UNO microcontroller. I have already my Arduino OPC skills to use the Arduino OPC serial server. For this, we have to include the OPC library in the Arduino IDE. So go to SCADA, include library, manage library, click on it. Libraries are downloading from internet, so you have to make online connection with your PC. Libraries have been downloaded. Now click here and write OPC. I have already my OPC library installed in Arduino IDE. If you do not already have this, there will be an option for installing OPC library, and you can easily install the OPC library in Arduino IDE. Now close this. Object declaration to establish communication between Arduino and Arduino OPC server. Our main case start from here, and this case is mainly to execute commands coming from the OPC client. Note that this is the OPC item that have been declared. The OPC items are D9, DI1, DI2, DI3, and so on. These OPC items will be available from OPC server to provide read-write data to OPC client. Now, it's the time to upload this program to Arduino UNO board. But before downloading this, we have to make some settings. At first, we have to select the Arduino board type. So click Tools, Board, Arduino UNO or Genuino UNO. I have already selected this. Next, we have to select the COM port. How to define the COM port? Just go to PC Properties. device manager, go to ports. Note that a Arduino USB cable have been plugged into the communication port number 3. So go back to Arduino IDE and click Tools, Port, select COM port 3. Now verify, we have to verify this OPC skills to check for any errors. So click on verify. This OPC skills are being verified. And compiling, we have found no errors. Now click on upload to upload this sketch to Arduino UNO board. Come uploading to Arduino UNO board. Done uploading. Now for checking available OPC items, just click real monitor, set carriage return, put cursor here and press enter. That Arduino have responded with the available OPC items. These OPC items will be available to the OPC clients via Arduino OPC server. Now to connect the Arduino UNO to any OPC client, for this case CX Supervisor software, we have to download the Arduino OPC server software from online, install this software on PC and finally configure this server. We can get the Arduino OPC server software from the website st4makers.com. So click on this browser to open it. Write the website address st4makers.com. We have come to the website. Go to the download option. Here is the download option for downloading Arduino OPC server. But I have already Arduino OPC server downloaded in this PC. So close this browser. Go to the folder. This PC documents. Folder Arduino OPC server where I have kept the downloaded file. So click to open it. This is the zip file for Arduino OPC server. So right click on this, click on extract here to unzip it. Note that the Arduino OPC server.x is the main file here. So double click on it to run this software. See that the OPC server software is running on this PC. Already we have get another two files, register.bat and register.bat. Click on this icon to get the full window. There are three tabs: information, configuration, info tab. Go to configuration tab for configuration OPC server. Click on Arduino serial. Select the serial port. Already I have connected the Arduino UNO board to my PC via COM port 3. So select COM port 3. Leave other setting just as the same. Click on sub configuration. Go to info tab. Here is the message waiting for OPC client to connect. That means no OPC client is now connected to this server yet. Minimize this server. Go back to the installation files. Any OPC server must be registered with the operating system running on this PC so that any clients can find it. We can restart this OPC server by clicking on restart.bat. Right click, run as administrator. OPC server has been registered with the operating system. You can also unregister the OPC server by just clicking on unregistered.bat. Now I will create a CX Supervisor applications in CX Supervisor software. Please note that CX Supervisor must be installed on your PC. I have already installed CX Supervisor on my PC. Now I open from the taskbar, click CX Supervisor icon. From file, new project, machine edition project, I give the file name this order. This is a page for creating user interface. Just double click on the title, or version. I can set center and full size. Okay, now the page is in full size. Now I'll create my graphical symbols on this page. First, follow the procedure for creating all the necessary graphical objects on this page. created our necessary objects for on this phase for our project, but at this moment these objects or user interface have no functionality or will not be able to control the motors on this user interface. For this we have to define some variables or points. Creating points, we must be connecting to Arduino OPC server running on this PC, and also the Arduino UNO hardware must be connected to our PC. For creating points, go to point editor, point. For controlling the motor in the forward direction, we have to add a point. So give the point name forward. Point type, we can set Boolean, IO type, set input output, on interval, update rate, we can set 50 millisecond. As we control the Arduino UNO board from our user interface via Arduino OPC server, so set OPC other for IO attributes. Now go to setup, server, add home run CX OPC communication control, select this, OK. Now add a project file, go to new, we can give the file name motor operation and change this motor operation SCADA. Just save this. We apply. So server name here Arduino OPC server, which is running on this PC. Now we apply and click OK. We can add a group on. OK. Item. Just click add. Go to browse. These are the OPC tags that provided by the Arduino OPC server, which is already running on this PC, and this Arduino OPC server collect data from the Arduino UNO hardware. So as we're creating a point for motor running in the forward direction, we can set Arduino serial DI on. Item valid, select. OK. 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 So we have created a point. This point name is forward. I am going to create remaining all the necessary points. We have completed creating all the necessary graphical objects and points, but we will not be able to control the Arduino UNO hardware from this user interface until we will not connect or assign a points to each of these objects. So one by one, we will connect or assign points for all of these objects. I have come to finish creating user interface. My user interface finally looks like this. Now it's the time to run this project. To run this project, click on run the project. But before to run this project, we have to ensure that Arduino OPC server is running on this PC. So click here. Note that Arduino OPC server is not running at this moment. So go to my Arduino OPC server file. Click on this file to run this Arduino OPC server. Now Arduino OPC server is running on this PC. So return to CX Supervisor project. The Arduino UNO board is already connected to the PC. So click on to run the CX Supervisor project. The file is loading now. Now my user interface is running on this PC. I am going to make DC motor operation from this user interface and finally in this video. Best of luck.